Hi, thanks for joining us at the Behavioural Software Club. I'm Andy Brown, and today we're going to be talking about the confidence limits we give around estimations. To start with, I'd like you to recall an earlier session. We plotted out project estimates and compared them to actual project deliveries so we could see the spread of errors in those estimates. We said that if those errors were entirely due to random chance events, we'd see as many projects overestimated as underestimated. Now, we know that's not what we see at all. Instead, we see something quite different. We see that most projects are underestimated, some to a significant degree. Almost no projects are overestimated. All well and good, but let's look at that graph again. Only this time, we'll also include the confidence limits. Here, we've only included a few project estimations, but you can get the general picture. Each bell curve represents the confidence limits for one estimate. If those confidence limits were estimated correctly, then the vertical line representing the actual deadline would lie within each of the bell curves. But that's not what we see, and that's telling us something very important. It's telling us when we estimate a project, we set our confidence limits far too narrow. In an earlier session, we estimated the length of the Golden Gate Bridge. When I first did this experiment, as well as estimating the length, I also got the students to give their 90% confidence limits for their estimation. The graph you're looking at shows the results of 10 students. Now, these are what students gave as their 90% confidence limits. In other words, 90% or 9 out of 10 of those vertical lines shown should intersect the true line. As you can see, only one of the 10 lines does. Therefore, what the students gave as 90% confidence limits were in fact 10% confidence limits. I've repeated this with various other estimations, and unless the students are specifically alerted to where the session is going, they invariably give overly narrow confidence limits. So, what is happening here? Well, there are two biases driving these overly narrow confidence limits, and you've met them both before. They are the anchoring effect and the overconfidence effect. Let's look at anchoring first. You may recall from our earlier session on anchoring that we anchor to an initial value, but then fail to adjust sufficiently far away from the anchor. So, how does this relate to confidence limits? When we estimate a value, this estimated value now acts as our anchor point for when we estimate the confidence limits. First, we take this estimation point, then we move upwards to get our upper confidence limit. Then we move downwards to get our lower confidence limit. But the anchoring effect causes us to move insufficiently far away from our start point, driving us towards overly narrow confidence limits. I mentioned there was a second bias driving this, and that bias is the overconfidence effect. So, how does the overconfidence effect cause overly narrow confidence limits? Well, as you recall, there are three facets to the overconfidence effect. Firstly, there's overestimation, which is excessive confidence in our actual abilities. Secondly, there's overplacement, which is an exaggerated belief that we are better than others on a given dimension. And thirdly, there's overprecision, which is an excessive belief that we know the truth. It's the third of these, overprecision, which drives those overly narrow confidence intervals. What's happening is that when we announce our estimated value, we have a confidence in it. In fact, we have too much confidence in it. So, when we come to estimate the possible variation or our confidence limits, then our high degree of confidence causes us to assign overly narrow confidence limits. Remember, anchoring, overconfidence, and all these other cognitive biases only exist in us today because they once provided our ancestors with an evolutionary fitness benefit. You'll recall that the anchoring effect occurs probably because our ancestors needed a fast and reliable process for estimation that was sufficiently accurate for their needs. You'll also recall that the overconfidence effect aided our ancestors in fights and competitions where we needed to maintain a belief in our own success, hopefully causing our rivals to back down before we had to do any serious fighting. There are several things you can do to try and address overly narrow confidence limits. First, as mentioned earlier, in addressing anchoring problems, you can try suggesting some extreme values. For example, if the estimate is 12 months plus or minus a month, ask the team, could it be as long as 2 years? As short as 6 months? This may be enough to get people thinking beyond the usual plus or minus 1 month. Secondly, as mentioned earlier, in addressing overconfidence issues, the books Super Forecasting by Philip Tetlock or Thinking in Bets by Annie Duke may provide a good antidote. If you've kept a history of previous project estimates and their confidence limits, then you can try revisiting those values. Simply looking at an estimate that has confidence limits of plus or minus 1 month when the actual project was delivered 6 months late can be quite sobering. However, if you are successful in addressing overly narrow confidence limits so that your estimates do have more realistic limits, then you need to manage expectations of those consuming the project estimations. Most people will be used to receiving an estimate with narrow confidence limits, say plus or minus 1 month. They know that those confidence limits are utter fiction, but that's what they've come to expect. If suddenly and without warning, you give them an estimate with more accurate confidence limits, say plus 6 months or minus 1 month, they're likely to begin wondering, what on earth is going on? If you don't warn them beforehand and educate them on why you are doing this, then you're probably storing up unnecessary trouble. If you've enjoyed this session, please give us a thumbs up on the link below. And if you're interested in this topic, please hit the subscribe button. Thanks for watching, and I hope to see you again soon.